for question 5, we're looking at a proof. Okay, so part A, prove, part B, show that. It's essentially the same idea, is that we're using algebra to get a result. So we can't at any point assume the result that we are given. We have to make sure that we are proving it algebraically. And there are a couple of different ways you can go about each of these. So first of all, prove that the mean, an arithmetic sequence has 15 terms, prove that the mean of these terms is the 8th term of the sequence. So just to get our head around the fact, what are we trying to prove? That the mean, which is the sum of 15 terms divided by 15, is equal to the 8th term. Okay, so this is kind of what we're trying to prove. We can't start by stating this as a fact. So what I'm going to do is start from the left-hand side. I know my formula for Sn, the sum of an arithmetic sequence. It's n over 2, u1 plus un. That's one version of it. Okay, and so that S15 then will be 15 over 2 of u1 plus u15. So the mean, which is S15 over 15, will be 15 over 2 times 15, u1 plus u15. It does feel quite repetitive when you're going through a proof, writing out each line really clearly. That is what's required here. Okay, what can I do now? Okay, let's cancel out those 15s, so I get half. And what is u15? Well, we also know that un of an arithmetic sequence is u1 plus n minus 1 d. So here are the formulae that are given. So this is going to be u1 plus 14d. So here I get half of 2u1 plus 14d, and I can expand those brackets with the half to give me u1 plus 7d, which is u8 again according to this formula. So that's done, and at the end of a proof you can write QED. I'll just show you here an alternative proof that would have also got you the marks. Would be to kind of write it out in full. So the mean of the terms would be all of those added up with. It's okay to leave a bit of a gap as long as it's clear what's there. So the sum of all the terms divided by 15. So we've got them all there divided by 15. Therefore we've got 15 u1s and 1 plus 2 plus 3 plus 4 all the way up to 14 d's, which gives us this line, and then we ending up with the same ending as before. So that's an alternative proof that would have been okay. Looking at part B, given that the 8th term is 30, show that the sum of the first and the last term is 60. Okay, what we can't do here is assume that the sum of the first and the last term is 60, because that's what we're being asked to show. The bit of information that we can use is that the 8th term is 30. Okay, and as we've got above, that means u1 plus 7d is 30. So this is a kind of fact that we can use in our proof or in our show. All right, so we want to show that the sum of the first and the last term is 60. Okay, so u1 plus un, where do I start with that? Well, I'm going to look back up here as well and use what I've got up here again. So I am going to jump around a little bit, but I've got u1 plus un, which is for this sequence just u1 plus u15, and using this I'm going to rearrange it to say that is the same as multiply up by 2 times the sum of 15 over 15. Then looking here, that is just u8. Okay, I've already got that from there, so that is 2 times u8, which is 2 times 30, which is 60. So that's done. Again, there are some alternative ways you could have used. So I've written an alternative here. Sn equals n over 2, but our total sum, this is just looking back at previous results, our sum of all the terms is 450. So you can substitute in a different order. The mark scheme as well was a much more succinct proof. Just work out the total, substitute that into the formula, and then rearrange. So there are a number of ways of doing it. All of them, though, follow the same pattern, that you're not assuming the result that you're trying to prove.